When creating 2D top-down player movement in Unity, there's plenty of ways of doing it, but unfortunately there aren't plenty of right ways of doing it. You see, if I hit play right now, I've set up a very simple script that lets the character move around. It seems to be working fine, and things seem to be going great. I've done it a very simple way that I'm going to show you in a second, but unfortunately I've done it the wrong way, and we'll start seeing why it's the wrong way when we start adding collision to our game. Unfortunately, it's very easy to do this, and it's very annoying to have to catch this later and change it. So I'm going to explain what I've done here, why it's wrong, and what we can do to fix it. So if I click on the player right here, this white box, I'll notice that I've added a rigid body 2D, it's dynamic. All I've done to this though is I've changed the gravity scale to 0 because I don't want the player moving around. Like falling off the screen, that is. And then I've got this script right here, which I wrote. And if I pull it up, we'll notice it's a very simple script. Just one thing happening in the update function. First of all, we've got this float move speed, which is set to a very small number, and this is a value I can adjust within the editor right over here to change how quickly the character moves. And then within the update method, which runs once every frame during the game, I take the player's current position and I set it to a new two-dimensional vector, an XY vector. So I take the current position and set it to a new position. This new position is equal to its old position plus the input I'm putting in the keyboard on like the horizontal and vertical keys, such as the arrow keys, times the movement speed. It's a very simple script, just the old position being set to its current position plus a little bit in some direction, either horizontal or vertical or both. And the result seems to be equally as simple and good. Once it compiles, the player moves around. It all works great. But what happens when we start adding collision? It's easy to add collision in Unity. All I have to do is add box collider 2D to the player, because it's a box. And then on this other NPC character, I can add a circle collider 2D, because it's a circle. It makes sense. When I hit play, we're going to see a couple problems off the bat. The first one is easy to fix. The other one's a little bit more finicky. So first of all, what we see is my character is rotating and sliding off the side, and now my player is all wonky right there. This is an easy fix though. If I go into the player, go into the rigid body, and under constraints right here, I can say freeze rotation along the z-axis, because the z-axis is the only thing that a two-dimensional figure can rotate around. So now that I've frozen rotation all along all axes which it can rotate, I'll notice that the player doesn't rotate when I run into this other NPC circle character. But we're noticing the real issue now. It's jittering. It's going in and then bouncing out, and if I stop moving it bounces out but then it goes back in. Yes, it's not moving through the circle, but this definitely isn't the effect we're looking for in 90% of the games we're going to make. So what's happening and how can we fix this? First of all, what's happening is our movement script. It's telling this transform component, here I'll pull up the script to show you exactly what I'm talking about. This script, every frame, is looking at this transform component, which is up here with that position, and saying, set the current position to this new position. I don't care if there's a collider there, I don't care if there's a rigid body, I don't care if there's another item there, go to this position whether you want to or not. So, because it's forced to, the transform component obliges and moves the item to that new position. Then the box colliders start recognizing that it's running into the circle collider, and both colliders start yelling at the rigid body, what are you doing? You can't be here, get out of here. And the rigid body, being a good dynamic rigid body, says okay and moves out of there. Then the player movement controller comes in again and says, well, we're getting input to move to the left, transform, move to that position. I don't care if there's colliders there, move there. And then the rigid body gets yelled at by the colliders again and moves out of there. And we get in this awful loop of everything yelling at everything. And we ultimately get the result of the box acting like it's triggered because it's very upset, trying to do something that it's not supposed to be doing. The key issue here is that we are hard coding this transform without talking to the rigid body. If we just talk to the rigid body, we would know that the colliders can't be overlapping, and the rigid body would not let us have moved in the first place, and we wouldn't get the jittering. Is there a way that we can fix this? Well, of course there is. Instead of writing straight to this position inside of the transform, there is a method inside of the rigid body which we can reference. It's called movePosition right here. This get component, so inside of this item, we're going to get the rigid body component, the rigid body 2D component, and then inside of rigid body 2D, there is a method called movePosition. It essentially does exactly what we're talking about right here, with a few changes under the hood, but it essentially does what we're doing right here, except we're talking to the rigid body instead of the transform. This way the rigid body can say, hold on, let's talk to the colliders, do they have a problem with this? If not, we'll move, otherwise we stay put. So if I copy this vector 2D and put it inside of this movePosition method instead, save that, come back over into Unity, we're now doing this much more correctly than we were previously. We're first going to want to change the movement speed to something a little bit higher, simply because we're using a different method. The speed dynamic is a little different. We see we're moving perfectly fine, and when we come over to the object, we smash right into it, and we don't bounce in or bounce around anymore. We're no longer triggered, everyone's happy, the transform isn't being forced to do things it shouldn't do, and the rigid body isn't finding itself in positions it shouldn't be. Are we done yet? It would seem like we are, and it seems like we could move on from this, and we're doing everything correctly. But we aren't, and this is important for us to catch right now, because this is something that would be easy to overlook until much later down the line. You see, the update function, as I mentioned before, runs every frame. It doesn't run a consistent number of times because frames aren't triggered a consistent number of times. If you've played games consistently enough, you may have noticed that sometimes you are running 60 frames per second, sometimes you're running 38 frames per second, sometimes you're running 200 frames. And this can fluctuate, and this will fluctuate based on 1, the computer that you're using, and 2, the amount of processes that the computer is having to do right now. So the more logic you add to the game and the other processes that you have running in the background, and the computer you own, is going to affect the speed at which your player is moving across the scene with this implementation, which is definitely not what we want. We don't want to be forcing people to buy the most powerful computers out there so they can zip across our scenes unnecessarily. Thankfully, the fix for this is easy. Instead of using update, which is going to run an inconsistent number of times, we use fixed update, which does exactly what it sounds. It runs a fixed number of times, specifically 50 times per second, but this can be changed within your project settings. So now, we're going to be running this a consistent number of times regardless of how powerful your computer is, and regardless of what your computer is currently doing in the background right now. I'm going to go ahead and save that. And I want to say that the rule of thumb right here is if you're doing changes like moving a player or adding force to an object, changes that may happen throughout rigid body physics, then you want to be using fixed update. The rule of thumb in Unity is if you're doing physics, do it in fixed update so that you don't get movement happening faster or unexpectedly within your update method. So now that we've saved that, we can come back to Unity, let the code compile, and when we hit play, we'll find that not much has changed. In fact, we can't really see anything that's changed. You may notice that the player seems to be moving more smoothly than it did at the beginning, but generally speaking, our collision works fine, and nothing interesting has happened. But we have made a very important change. Again, this is not for cosmetics. This is not a suggested change. This is an absolute necessity. You don't want to be running any of this code in update, and it may be hard to notice the differences at this point, but down the road, this movement speed and the speed at which your computer's running, all of these things could fluctuate what this number should be if you're doing an update, and it's just going to be a train wreck if you don't catch this early. I hope you found this video informative and helpful. If so, please go ahead and like it. Thank you so much for watching, and I'll see you in the next one.